My talk is titled More on GDB. GDB here states for new debug. More because I tried to give a similar talk last year here at FOSDEM, so I tried to extend it a bit and make it more useful. Because the rest is for MySQL DBAs. It's a bit strange. DBA work in production should not do debugging and are not expected to do debugging with a live MySQL. But sometimes it helps. So let me proceed. I started to work on MySQL as support engineer 10.5 years ago in MySQL. I'm still doing that. Just a couple of days ago I left Recona where I spent the last 3 years. I'm doing support, and all this time I'm also working on bugs in MySQL. This is how I ended up with talks like that. And that's why you will see bug numbers too often on these slides. Not so many slides, but they will be full of bug numbers. This is how I think about MySQL in terms of bugs, mostly. That's it. You can see some links also to other sites and resources I'm interested in and where you can find me. I write about bugs, I speculate about bugs, I verify bugs, I report bugs. So, that's how it starts. And I just would like to say that one of the most important information resources related to MySQL is public bugs database, because it contains not only bad things explained there, but it also contains workarounds, solutions, quotes from the manuals, extensions to the manuals, and everything. So if you will get a habit to deal with every MySQL-related problems by searching bugs database among other sources, you will resolve your problems faster. So it was not my invention, by all means, to try to attach to MySQL D to the running process and get something useful with a debugger. We work on open source software, so we have access to the source code. So whenever we need to understand MySQL, or whenever we need to study some problem, we can go directly to the source. Debugger, whatever, GDB is just the most widely used example, as we mostly use MySQL now and read first of all, it's natural. So debugger just helps study code in a more interactive way. So I will present some history, who started that, how it started, what crazy things people started to do with debugger and why. I will present some names. Some of the studies ended up with separate tools. Of them, PT, PNP, or Poor Man's Profile by Dbas is the most widely known, and it's now a part of the production-ready performer toolkit that is widely used. And I will just show how it works, in a few examples. What part of the code you need to study, how you can do that, and few GDB commands that will be of the most use in the process. I also added, comparing to last year, a couple of things that I recently was working on using GDB, specifically studying how looking works in MySQL. Because you can read the manual, you can get a lot of commands at SQL level to see that, but depending on version, you may not have all things covered. And depending on how fast you are typing, you may not be able to catch up all the steps. GDB is a unique tool. Unfortunately or fortunately, to find out how exactly looking happens in sequence, in what order. And that helps to then explain production problems like delogs or hanging sessions or whatever. So that's it. Naturally, debugger was first used by developers. I just give you a couple of examples. As a support engineer, we usually came to developers with a problem like, MySQL is crashing at customer side. Customer does not know how it happens. They do not have anything useful in the log. What they have a core dump. So can you please check the core dump and find out something? So we have to provide the binary, the crashing binary, maybe the GNU library for it, and the core, and got a magic out of developers. So they say, it was this SQL statement. How do you do that? I don't know. Check bug numbers, you will see what magic developers can do. For example, studying cores. They also surely use GDB as one of their tools in their usual tool chain. When they debug their own code, they can use it as an interactive tool as well. And I just would like to show you the example what you can do with GDB. You can run your software under GDB. So you compose a command line starting with GDB. You pass arguments, and for example, this is the way to run Mysql chat under GDB. And then you can set breakpoints, watch points, run it step by step, whatever. So this is how developers use it. And once again, I just would like to, in other cases, another option how to use it is to attach it to already running MySQL. So you can put MySQL server into some problematic state if you know how. And then you can study it from that position. So running step by step in GDB will take you years. So you can just attach it at the right moment. Again, just a couple of recent examples. What magic developers can do. There was a huge problem, for example, in MySQL, resolved eventually completely by Oracle, by the way, that you were able to use save points, integers, but that broken up all kinds of replication, error replication, binary logs, and everything. And still, the commands were supported. So just take a look, all links are clickable, slides, check how many states were needed. Another option, yet another my colleague from Percona, who works in support, Nikolai spent some time clearly by a couple of commands comparing variables in GDB, and he was able to pinpoint why specifically the crash happened in one quite a complicated case. So no doubts, developers use GDB and can get a good use of it. What about DBAs? For DBAs, it's important that GDB allows you to get something useful out of the MySQL D binary that otherwise you cannot even access. So you may not be able to connect to MySQL D with any client. You cannot open a connection. Maybe you hit max connections limit. Maybe your server is overloaded, but the process is there. It's in some state. You just cannot get it. Here comes GDB. You can attach it, and as soon as you know which variables are there at the global level, or you know which threads are there, you can take a look. You can switch from thread to thread, what local variables are used in each and every function. You open the code snippets just in another window, study the code, try to guess, find out, remember, write down, get prepared. So you do it already when MySQL D is handled. I mean, it's not bad, it's possible even for production DBAs. What options you have? You can collect some final evidence before restarting it, or you can just restart it. Restart and move on, restart and move on. You do it every day, many times. It's typical for DBAs, but when you restart it and start to understand there is some trend, it fails too often, there is a reason to do something else. And that can be attaching GDB and check. So GDB basically allows you to check values in memory of MySQL D or any other process, if you know the code. Moreover, it allows you to change values that you may not be able to change otherwise because you cannot connect, or because we are speaking about read-only variable, some limitation in MySQL, whatever. And surely, GDB can be used by DBAs as well to study evidence later. So all you should do, probably if you are going to find the root cause of each and every crash, the minimal thing you should do, you should make sure that you have core dumps saved, and then you can spend your time in GDB on them later. Restart fast, move production in order fast, but study evidence later. So that's it. Initially, the new approach, or absolutely unthinkable approach, is to use GDB to change weight. It needs some training. And initially, at least from my understanding, these tricks were implemented and widely used by a well-known MySQL guy, a big guy in MySQL, who is now in Facebook, Dbas. So he used all kinds of tools. So as soon as he worked on MacOS or Solaris, he used dtrace. When he worked on Linux, and there was no dtrace at the moment, or no completed implementation, he had to use GDB. He used all kinds of tools. So he started with various commands like, what if I need to add, for example, a replication field for slave without restarting? Or what if I would like to enable log slave updates? it requires slave starts, but I cannot afford that in production. What if I would like to disable read ahead at MySQL level because it kills performance, it requires restart? So he studied the code and did all the tricks. But he was really famous for poor man's profiler that started just with a simple idea. Let's do a backtrace for each thread to see what it does. Where is it now and how it comes from there. When you do it many times for the same thread, you may find some trend. Like it's handing, it's the same call stack all the time. Or all threads are handing in similar stack traces. So he just written a script, a combination of AWK and shell to analyze, summarize stack traces, remove specific thread numbers or whatever, and count similar traces. And these two eventually ended up with a separate site. It was a bit improved, rewritten, options added, and it's now a poor man's profiler with TPMP that you surely have to try to run whenever you see your MySQL D hangs and plan to restart. Even if you do not have core dump enabled, no need to kill or provoke killing. You can shut it down cleanly if it replies to your comments. But before that, get the stack traces, get them aggregated at least. Or you can do it in GDB once. But getting them aggregated will give you extra information because it's state in progress or in no progress. That's great. There are other examples. For this slide, I'd like to concentrate on the following. Initially, 10 years ago, it was like black magic, as I explained. When a developer, an experienced engineer, could give you a crash in SQL from your core dump that he was just able, or all the SQL that was executed at the moment of crash, because sometimes the crashing session cannot explain anything. You repeat the same SQL and you do not get the crash. It should happen in specific state and situation. So there are several articles listed there, and you should remember names of people like Shane Wester and Roland Dbas, who is now leading QA in Perform, that made like entire business cases out of getting SQL from the core dumps. So they created tools and approaches around GDB that help you to get all the SQL statements that you had at the moment of crash. And this is a basis of QA efforts in Perform right now. So they write all kinds of code until they see crash, and when they get crash, they get a core dump, and when they get a core dump, they automated the process. They can reduce and build repeatable test cases. So now, if you ask me, most of the QA efforts in MySQL land are led by Perform using this specific approach. So it's like servers working 24 hours per day, running all kinds of crazy generated commands that maybe even do not make sense, and eventually hitting problems. Crashing server, hitting assertions if it's debugging version, or just crash it in reality. So remember the names, and you can easily Google for more links. These links I just suggested. So you are just MySQL DBA. What you can do with GDB? Basic commands are quite simple. First one that you should remember, thread reply all backtrace or BT. That's if you have a hanging server, if you do not have Perform toolkit installed, no PTPMP or anything, get at least a single snapshot. Then, after you analyze that, you will see which threads, which numbers, what they do, are composing your MySQL process state at the moment. You can switch to a specific thread and study its content. You can see how you get from thread creation to current state, which functions were called, which structures are involved, and you can print the values of these structures. So the next command you know is print, simply P in short. Then the command you should know if you are going to use GDB and change something is set command. You can change the value of any variable. It can be a global variable, and you have even help from GDB, like you press tab and it will give hints you, like you have in shell. It will give you hints for variables auto-completion and then lists of accessible variables as soon as you have symbols there. So you can change max connections on the fly, it's a global variable. You can change log slave of days on the fly, it's a global variable. Another more interesting thing, you can call functions from MySQL code in GDB. Like you change the way MySQL server works. the function may do a set of complicated steps in a proper manner, in a proper order, unlike if you will set variables yourself or create some additional user variables yourself. So you can call functions. As far as I understand, Dbas was one of the first to apply to error replication filtering behavior. That now in 5.7 finally it's dynamic. Net replication filters dynamically. One of the final slides I will say about that GDB is actually for you when you hit limitation of MySQL. But eventually, this limitation is pinpointed, POSQL coordinate may be worked out and you are resolved. So you can work interactively, or you should, in production, you should know how to apply benchmarks. So you prepare in testing environment interactively, but then you should be ready in production to run batch command. Because when GDB is attached, nothing happens, because it's a stop until you let it run. That's it. Okay. So I will not say anything more about Poorman's profiler. It's a great tool. Just check the number of bug reports. They are not the most recent. There are still great examples, and as far as I remember, some of them are still not resolved. So where PTP and PCAP. What you should remember, and you should know about GDB in case of MySQL is the following. MySQL is written so that it's a single process that creates multiple threads. So you need to know how to debug multi-threading problems. That's all. And actually, maybe a couple of comments, a single link of what you need. So you have a process, it's composed of several threads, always. Some ground threads and user threads. In each thread, you can switch to if you need to put yourself in that context, if you need to change some variable, as it's for this thread, or see the variable in this thread. You move to a specific thread, you can see a sequence of calls, backtrace, and then you can move to each of these specific calls, called frame by number, and see what was in this frame, if it's not visible for you. You see the function there, you can check the code, you can see all the local variables, you can try to get things out of it. And surely, if you know how to name complicated structures, you can directly get a query string, for example, for a specific thread that is a pointer, you get a query string, but it's a bit complicated, it's not like a string directly. There are several structures, one another, you point out and you get SQL. That's basically how people get SQL, essentially. From any thread that they can get a thread structure, if it was executed SQL. You move to a specific frame, you get SQL, that's it. I highlighted just several items of thread structure. Surely among the first things in the code that you should check, you should find out, open, and study thread structure. It's huge. It's complicated. It's a class that is a descendant of other classes. It has substructures and everything. The more you know about it, the better you can imagine what to do. But essentially, you can just get a question. A year ago, I got a question: how to find out what user really had executed specific code. It was like a stored procedure. What was the efficient user? Because you have a creator and a definer for procedure, but it may run as definer, it may run as a call. So it took like 10 minutes to find out. You just dump, you print the thread content, and eventually you grab for familiar items, try to guess, and you can see that, for example, in this specific case, the code was executed as a root from local host, because the customer asked, who could run that? I cannot imagine, it's not possible. This user cannot log in, we disable it, but it was a stored procedure after all that was created as root. As we probably do not have that much time, just a quick comment. So this is what happens with core dump, a set of commands that you should have ready if you would like to capture the momentary state with all the details and cannot effort storing core dumps that can be many gigabytes in size. Just get a backtrace from core dump, then you can throw it away. If you need to know how to create a core dump, there is a set of steps, as far as I remember. Oleg had written a nice blog post, and Peter Feitzer had written it as well. So make sure you followed it, because it matters. For example, for production MySQL D, not the testing one, it runs as root, so you should make sure that core dumps are created by root users, where they are stored, that are numbered by process ID, if you have to store several of them. So there are some small details. As for crashing bug, I had a small problem. The crashing bug I referred to a year ago, it's fixed in 6.28, and it's not fixed at work. That's why I left it on the slide. And you can double check, because the crashing code that you can use to crash actually whatever MySQL is still visible. But I've picked up, yes, another bug, so basically, well, here it has to be a bit different. Basically, this is how it works. I crashed MySQL based on finding of Percona QA, and that's what you have when you attach GDB. I just wanted to show how it looks like, and one important thing that often is a problem. What you see, reading symbols from. If you are using MySQL binary without symbols, you may get a problem, cannot read symbols from. So in case of Percona server, there is a separate package with symbolic information. In case of Oracle, it's included. In case of other vendor, I haven't checked my ADG. So you should get ready. So you should make sure that if you attach GDB, you have symbolic information there. So like that, nothing special. Just a couple of slides about my recent findings in the process are like that. So to attach to a live MySQL it's still easy. I will just show you probably. It is a part of questions. So recently, during last year, I started to use GDB, not in production only, but when working on complicated locking-related problems. So if you need to find out how locking happens in MySQL, specifically if we speak about InnoDB logs, it's easy. You need to read the code, guess or find by testing functions that are called when logs are set. Specifically in InnoDB, it's log table and log track log. Quite simple name, easy to guess. You set breakpoints, then you let GDB to continue, so let it run. Then you run whatever SQL you want, and you will get breakpoints in GDB. You just log it, get a log, and you will see in what sequence, in what order, which logs are requested. You will see sometimes even log names or log modes resolved to symbols with symbolic information. If you cannot see, you see just numbers, okay, then you just go to the code and study it. Same applies to metadata logs. In 5.7, you can see metadata logs in performance schema table, but before 5.7, you have no visibility of what actually is logging you. So that's easy. We found out there are a couple of candidates. First of all, MDL request, it's a class. Init, it's a member function. Set breakpoint on it, and you will see every metadata log request. You easily end up with some conclusions, and I presented my conclusions here in form of blog posts, bug reports, requests to improve the manual. It's just a top of the iceberg. Recent one that are not featured. So, to summarize, what you can do, surely you can study MySQL better. Surely you can resolve some immediate limitations. Is GDB an ultimate answer? Well, ideally it isn't. So if you're resolving performance problems, you can start with poor man's profile. But eventually, because it doesn't have any timing information, it just has an aggregated text, you may have a need to use real profile to find where time is spent when something ends. So hand is easy, but slow performance is less easy, and just stack traces may not help. If you're studying performance problem in production, attaching GDB is stopping each time, so it has a performance. Surely, if you have this information from performance schema and it's enabled, you should use it. You should run it at SQL level. And surely, some forks like MyADB, for example, or 5.7 of MySQL allows you to study metadata logs in another way. But when you can just use GDB. This photo of me was taken 10 years ago, and I attached GDB maybe for the first time myself. There is a path. So the path is open. It's somewhere far away where you may end up if you use GDB. Please do it, and when you hit the bug, when you see something that you cannot explain by the manual, report it at bugs MySQL or at whatever bug tracker that applies to the version of 4. Thank you very much.